Most surveillance cameras sold today are easy to hack. This is due to a severe vulnerability that manufacturers have ignored for about 7 years. Hacking such cameras is so simple that it only takes sending a specific command to get their login and password. Why can't this camera be hacked? It has no direct internet access, so it can't be discovered by online scanners. Why is hacking cameras dangerous? There are frequent cases where attackers connect to cameras and harass people. It's even worse when they scare children, so protection here is especially important.
Who is that?
I'm your best friend. I'm Santa Claus.
In this video, I'll show an expensive and a cheap camera option. I'll compare their quality and show you how to set them up. The first option is more expensive. You'll need a Raspberry Pi board, in my case version 5, but you can also use the cheaper version 3, which is sufficient for this project. You'll also need a camera and a flash drive, a servo control board, servos, a power supply, and wires. Additionally, you'll need to print the case on a 3D printer. Here's what all the parts that need to be assembled look like. All links will be in the video description. For aesthetics, you can paint them. First, I primed them for better paint adhesion and then used black matte paint. While they dry, I can assemble and configure the electronics. I should be setting up the system now, but I always run into problems that shouldn't be there. The fan doesn't work in it, or rather it works, but the board doesn't turn it on. I couldn't solve this problem, and I didn't find a solution on forums either, so I disconnected the 2 wires responsible for power and soldered an extra wire to reach the power pins. This ground wire I connect to ground, and the positive wire can be connected to the 3.3 volt pin, which will make the fan run at half power, or to the 5 volt pin for maximum cooling. Now everything works. I insert the memory card into the computer and go to the website the installer to the computer and run it. I select the microcontroller type. I have a Raspberry Pi 5, but you can use version 3. It's twice as cheap and more than enough for this project. I choose the operating system and specify the flash drive where the system will be installed, then click Next. The installation will take a few minutes. I insert the flash drive into the microcontroller and I connect the mini HDMI cable, power cable, and the system boots up, ready for configuration. It's better to use a wired mouse and keyboard for this, but my Bluetooth mouse connected itself. Here, click Next and check these boxes. I don't have the keyboard connected yet, so I click here to add a Bluetooth keyboard. Create a login and password for the system. You'll need to remember it for later. Connect to the Wi-Fi access point and enter the router password. Agree to everything and the system will reboot. Just a bit more to go. For convenience, I'll enable remote system management so I can disconnect from the monitor and control it from the computer. Go to the main menu, Settings, and select Configuration. Go to the Interface tab and enable VNC and T2C. Click OK, then restart again. Open the terminal and enter this command to install the remote access package. Now this one to find out the assigned IP address. Turn off the system and disconnect the video cable. Restart and move to the computer to connect to it. You'll need the real VNC viewer program for this. Download it from the website. It's paid but free for 2 weeks. After installation, launch it and click here to add a new device. Enter the IP address and connect. Enter the username and password you set during system setup. Finally, you can manage it properly. I'll start installing the necessary libraries. Open the terminal and enter the commands. All commands will be in the video description and on the GitHub page. Just copy, paste, and press enter. If you encounter an issue like I did, fix it with this command. Then repeat the previous command and everything works. Create a project folder, a camera script file, open it with a text editor, and insert the code. Save it. A new template folder with an index.html file, open it with a text editor and insert the code. Save it and start the program. Assembly. Connect the wires to the servo controller in this order. It also needs separate power. I made a USB cable for power. The USB goes to the Raspberry Pi and the wires to the servo controller. Black is ground and red is positive. Connect the other end of the wire to the Raspberry Pi as per this scheme. Assemble the case with the electronics. Install the camera and connect the rotating mechanism to the servo. Connect the servo and camera. Everything is ready for use. To control the camera from a computer or phone, enter the camera's IP address in the browser, and a window with video and a control slider will load. The servo reacts to turns with a delay, which I'm sure can be fixed, but it will take time. Since I spent a week trying to implement this with another module, the ESP, which I'll talk about later, and another week to make it on the Raspberry Pi, it will take a few more days to smooth out the servo movement, and I aim to complete one project per week. So, I'm falling behind schedule. I'll update the code and upload it to GitHub later. The second option for $8. Initially, I wanted to make this project on the ESP32 module, an interesting family of microcontrollers, but it's problematic due to its flawed libraries. I'll test the cameras to clearly show the difference. I won't test the ESP32 cam module as it's outdated and costs the same as new models. We'll check the Rover and Rover S3 and of course compare them with the Raspberry Pi. The Raspberry Pi, everything is smooth, the picture is clear, and the light sensitivity is much higher. The Rover image looks okay if you don't move it, but the picture blurs significantly with movement. The Rover S3 plays video better, but blurring is still present. Overall, the image is quite watchable, and would suit this project if not for library issues. As you can see, the ESP would suffice for many tasks, but I couldn't manage to output streaming video and control the servo motor simultaneously. One or the other can work. I spent a week on this and couldn't solve the problem. AI didn't help either, but if you need just a stationary camera, it might suit you. It takes up significantly less space. If you decide you need the ESP32 camera, here's how to set it up. Download and install Arduino IDE from the website. Launch the application. Connect the board to the computer. Select the module model and COM port. Go to Files Examples and select ESP32 camera, Camera Web Server. In the code, comment out this line, and for your module, uncomment it. Enter your network password and login. It's very important that your settings match mine. Now click Upload Sketch and wait until it's fully uploaded. After uploading, press this button on the board. Open the serial monitor to find the IP address the camera is connected to. Enter it in the browser and you can use the camera. It's crucial to place a spacer between the camera module and the shield, or it will short-circuit and hang. Thanks for watching, and be happy.